We're going to look at section 5.2 and dive into some of your homework problems. This section has some challenging problems and it just really kind of makes you think through some things. So let's see if we can get you some help. First thing we have to know is the definition of divisibility. So here you have a formal definition. If m and d are natural numbers, and if there is another natural number, k, so that m equals d times k, we say that d divides m. Okay, I know that these formal definitions are really confusing, so we'll try to put them in plain English for you. You see this symbol right here, D, and then this straight up and down line, M. That means this right here, D divides M. So if you see this 5 and then line 35, that means there's some natural number K, which actually we know is actually 7, such that 35 is equal to 5 times K. And in everyday backwards Alabama language, that means that 35 divided by 5 is equal to a whole number. There's no decimals involved, okay? So that's as plain Jane simple as I can get you. It divides evenly. So if it divides evenly, then we can have that symbol there. All right, let's look at some examples. On your homework, you're going to have several of these. Are the statements true or false? So here we want to know, does 16 divide 438? So will 16 go into 438? Well, if you take 438 and divide by 16, you get 27.375. That is not a nice, pretty, whole, natural number. It has a decimal. So actually, that is false. Okay. Now let's look at the next one. So 21, does 21 divide 1323? So we're going to take that 1323 divide by 21. We get a nice, pretty answer of 63. So in this case, that is true. So those examples in your homework should be, grab a calculator, and they should be fairly straightforward. Now we're going to look at prime numbers. Okay, you have definition here. A prime number is a natural number that has exactly 2 divisors. Okay, that's very important. It has 2 divisors. A natural number that has more than 2 divisors is called a composite number. So if you're not a prime number, you can be a composite number. Okay, so let's look at an example of a couple of prime numbers. The number 2 has divisors of 2 and 1. Those are the 2 numbers that will divide into 2. 7 has divisors of 7 and 1. Those are the 2 numbers that divide into 7. So pretty much a prime number has a divisor of itself and 1. So that's what a prime number is. Now, and one thing to note here is that 1 is not prime or composite because 1 only has itself as a divisor. And in order to be a prime number, you have to have exactly 2 divisors. So, there is no other number. And composite would be if it has more than 2 divisors. So 1 is just a special number. So we call it very special, and it has lots of unique properties that we'll go into some, but not many. Okay, let's look at some more examples. This is a screen that if I were you, I would print this slide out or write these numbers down because this will make your life a whole lot easier in this section. These are the prime numbers from 1 to 100. Now, if you go through Dr. Farmer's lectures and also looking in your textbook, they will tell you a lengthy process of how they came about finding these numbers. I just decided to just give them to you because you're going to need them. So these are all the numbers, and I tried to kind of group them into groups of 20. So like this first row is the prime numbers from 2 to 20. This is 20 to 40, 40 to 60, 60 to 80, and 80 to 100. So that way you can just have an easy reference to go by. We will be referring to these numbers quite a bit for the rest of this lesson. So how would you figure out if a number is prime or not? Okay, so remember it only has itself as a divisor and 1. So if we find any other divisors, then it's not a prime number. But there is actually kind of a mathematical step-by-step way of determining if it's a prime number. Some numbers are easy, but other numbers are not. So let's take a look at this one, 56. The first step is to take the square root of the number and round up to the next whole number. So I took the square root of 56 and I got this 7.48, and I'm going to round that up to the next number, which is 8. Okay, so that's step 1. Step 2 is to see if your number that we started with, 56, is divisible by any prime number that is less than 8. And remember, 8 came from this answer right here. Okay, so if I look at those prime numbers, the numbers that are less than 8 are 2, 3, 5, and 7. Well, 2 divides into 56, so the answer is yes. Now, step 3, if your answer is yes, that means it is not prime. If the answer is no, that means it is prime. Okay, so 56, if it's an even number, it's not going to be prime. So because all even numbers are divisible by 2. So that was kind of 56. You didn't necessarily have to take all these steps, but now let's look at one that's a little bit harder to see. So here we have what I call not an easy number, 3,167. Okay, off the top of my head, I have no idea if 3,167 is prime. And I sure don't want to have to divide it by a gazillion numbers to try to figure out if anything will divide into it. If you're like me, I take a few numbers and then I kind of just give up because I'm just like, well, if it's not any of those, then I'm just going to say it probably is prime. So, but let's take these steps and see if it helps us some. So remember, step 1 was to take the square root and round up to the next whole number. So the square root of 3167 is 56.27 blah blah. And so I'm going to round that to 57. Now, step 2 is to see if 3167 is divisible by any prime numbers that are less than 57. So I'm going to list out all the prime numbers that are less than 57. And it turns out that there are quite a few of them. Okay, so we do have quite a few numbers here, but this is a whole lot smaller list than if we just started dividing by every number that's less than 3,167. So this takes the task down to a very minimal amount. So I grabbed my calculator, I put in 3167, I divided, and I just started dividing by all of these numbers. Okay, well, I went through every single one of them, and it turns out that none of them will divide into 3,167. So the answer is no. That means this is a prime number. Okay, so that's just kind of maybe a shortcut for you to take when the numbers are not so obvious when they're large numbers. All right. Now we're going to talk about prime factorization. Whenever you talk about prime factorization, it means that you want to write the number as a product, which means multiply, of prime numbers. All right, so this is where that prime number sheet, again, comes in handy. Let's find the prime factorization for the number. So I'm going to start with a number 24. And you may have seen this done before using what I call a factor tree. So I'm going to think of two numbers that when you multiply them together, you get 24. And so in my mind, immediately I think of 6 and 4. Now, I can't stop until both of these numbers, all of the numbers that are down here, are prime numbers. Well, 6 and 4, neither one of those are prime. So I'm going to have to do all of this again. So I'm going to take 6 and I'm going to find factors that multiply to be 6 and factors that multiply to be 4. So for 6, the obvious choice is 2 times 3. For 4, the obvious choice is 2 times 2. Now we're going to look at all of our numbers. So all of these, 2, 3, 2, 2, those are all prime numbers. So that means I'm done. So I could say that 24 could be written as 2 times 3 times 2 times 2. And that's going to be your prime factorization. Now, in your homework, you're going to have to write this out. And when you do this, there is actually a, like over on the right side of your screen, at least that's where it shows up on mine, there's a little math type pad, and you can actually put in multiply. You can also, if you type the little asterisk key, which is the little star thing above the number 8 on your keyboard, that will end up turning into that dot too. So just some ways to help you make sure you get your numbers in right for your homework. Okay, now we have this really weird thing that's called a canonical prime factorization. I really don't like this, but it is just something that is very unique. I mean, it is, it'll just kind of blow your mind. But basically, this is a prime factorization where you include all prime numbers that are less than your largest factor. So we're going to look at an example, and you do have one like this on your homework. So let's look at the number 377. So I'm going to divide that up, and it turns out that it is actually equal to 13 times 29. Well, 13 and 29 are actually both prime numbers. So if you were just doing a plain Jane prime factorization, you'd be good. You'd be done, 13 times 29. But we're doing a canonical prime factorization. So you have to include every prime number less than 29 because 29 is your largest factor. So here's where this little thing comes in handy. Any number raised to the 0 power is 1. Okay, and so what I'm going to do, if you multiply 1 times any number, you haven't changed anything. So I am going to take this little secret, and I'm going to add in all of the factors that are prime numbers that are less than 29. And if I don't need them in my prime factorization, then I'm going to write them like this. Okay, so here is how this works out. I have all of these prime numbers. I had 2, 3, 5, 7, 11. Okay, there's my 13. I need it to be to the first power because that gives me this number right here. Then 17, 19, 23, and then I finally have 29. Now, that is canonical prime factorization. Notice that all of these ones that I didn't really need, I put to the 0 power, which is secretly just 1. So 1 times 1 times 1 times 1 times 1 times 13 is 13. Times 1 times 1 times 1 times 29 gives me my number of 377. So when you write this problem out and it asks you for the canonical prime factorization, this is what it wants. So it takes a little practicing for you to use that little math type pad to get the exponent in there, but that's how it should look. Okay, now that we talked about the greatest common factor, we're going to talk about one that is similar to it, but this is called a least common multiple. And I'm going to use the same exact set, and you have to do the same thing. You have to find the factor tree for all of your numbers in the set. So since we've already done that in the last slide, all of that hard part is already done. So now let's talk about a least common multiple. Well, the least common multiple, we are going to start with our first set of multiples here. So 2 times 3 times 5. My least common multiple has to have every one of those multiples in it. So I'm going to go ahead and say that my least common multiple, I know will have a 2, 3, and a 5. Okay, so that takes care of the first one. All right, now the second set, when I go over here to 75, it has to have a 5, and a 3. Well, I have a 5, I have a 3, but I need another 5, okay? So that one is going to add another 5 to it. If I have that, then that takes care of the second number. Now my third number has to have a 7, a 3, and a 5. Well, I have the 3, I have at least one 5, but I don't have the 7. So that means I've got to pull that factor in here. So I'm going to put that 7 in there. Now, between all of these numbers right here, satisfy every single factor that's up here. So now all I have to do to find my least common multiple is to multiply all of these numbers out. And when you multiply all those numbers out, you get 210. So 210 is going to be the least common multiple of 30, 75, and 105. All right, this is going to be our last example, and it's going to require just a little bit more work because we got to really kind of think about it. So what is the smallest natural number that is divisible by the first 10 counting numbers? Now, you have one that's similar to this. Instead of the first 10, it's another number. I can't remember which one it is. But anyway, so I'm looking at these first 10 counting numbers right here. So I have them out here for our reference. Okay, so really this boils down to what is the least common multiple of all of these numbers? Well, if you could do a quick factor tree for every number, that would help us out. But I'm just going to kind of write these numbers in. I'm going to try to write it with my mouse, so it may not look that pretty. So to satisfy this 1, I'm going to need a 1. Okay, and then I'm going to need, for 2, if you do the prime factorization of 2, it would be 2 times 1. So I already have the 1. So now I need a 2. There. That's an ugly 2, but it'll be there. Okay, now to get 3, the prime factorization of 3 will be 3 times 1. So I need a 3. Okay, and then the prime factorization of 4, if you can imagine, 4 would be 2 times 2. So I have 1 2, but I need another 2. So I'm going to have to add in another 2. Okay, so that got 4. Now we go to 5. 5, the prime factorization of that would be 5 times 1. So I'm going to add in a 5. Okay, 6. 6 is going to be 2 times 3. Well, I already have, I have 2 and I have 3. So that takes care of 6. Now let's look at 7. And 7 is going to be 7 times 1. So I'm going to need a 7. All right. And then let's look at 8. Okay, when you think about 8, 8 will break up into 4 times 2. But then 4 is going to break up into 2 times 2. So you're actually going to have 2 times 2 times 2. So 8 requires 3 2's. Well, I have 1 2, I have 2 2's. I need another 2. So let's put in another 2 in here. So I'm going to put in my other 2. And then let's see, that was 8. Now 9. 9 will break up into 3 times 3. I have 1 3, so I'm going to need another 3. And so here's another 3. And then 10, let's see, 10 is going to be 5 times 2. And I already have, let's see, I have 5 times 2. So I have a 5 and a 2. So I'm okay. These are all of the numbers. So now all that's left is to multiply all of these numbers together. And when you multiply all of these numbers together, you should get a big number of 2,520. All right, that's very ugly. I'm not impressed with my mouse. Actually, it's the touchpad on my laptop, so I'm not at all impressed with my little touchpad. Yeah, it didn't work out so good. I'm sorry. But you get the point, hopefully. So the answer here is actually 2,520. Okay, I think that's going to wrap this section up. Maybe before I do this again, I'll edit this and actually put the numbers in. I just kind of ran out of time. All right, I hope this helps you guys. Let me know if you have any problems, and I'll be more than happy to try to explain some more to you. Thanks a lot.